Good morning, everybody. I'm here to present you some of the results that we obtained in the project, in the Seafood Tomorrow project, regarding task 1.1, which was focused on the use of novel sustainable feed ingredients to tailor-made or customized farmed fish. And in this respect, mainly the concept of biofortifying with some health valuable nutrients. And of course, also in association, the project has run some activities on the potential use of multi-trophic aquaculture. Let me switch. It's not changing. Okay, so all of you know that the aquaculture is gaining a huge relevance in terms of the seafood supply. In a global scale, it's even outpaced the supply originating from wild fisheries. And we know that in the next decades, aquaculture will grow. And this growth has to be done in a sort of a sustainable way. So farmed fish and fish in general are identified as a very rich source of several nutrients. Of course, highly digestible proteins, several vitamins, mainly vitamin A, vitamin D, vitamin B12, and also some selected minerals that are typical, especially in marine fish, of selenium, iodine, but, and the most famous, of course, are the omega-3 fatty acids, EPA and DHA, that you all know that these nutrients in the overall play an important role in the human health aspects. However, what we have also seen over time is this trend that is something that is a reality throughout the aquaculture industry, which is a reduction on the use of fish meal and fish oil for, let's say, sustainable issues. And what we also perceive to some extent, it's not that it's a huge drop, but these changes on the composition of the ingredients that are used on aquafeeds can lead to some changes on what was a typical nutritional value of fish. Namely, by reducing the fish oil in the diets, we will have lower levels of EPA and DHA accumulated in the fish itself, and also lower levels of some of these minerals that I mentioned. And here in the project, we are focused on iodine and selenium. And so the idea, what we wanted to test in the seafood project was a strategy to counteract this potential loss of nutritional value of fish as a human food. And for this, the approach, as I mentioned, is the biofortification with health valuable nutrients, health valuable for humans. And the concept, of course, it's put here in a very simplistic way, which is we will make a feed supplemented with a given nutrient. This feed will be fed to the fish, does not have to be fed throughout the entire production cycle. It can be fed as a finishing strategy. It means a few months prior to harvest. In general, 2 months is more or less enough. More is better to have a higher standardization, but our data show us that 2 months are enough. And of course, this will result with fish fillets with a higher content of the target nutrient. However, there is one aspect that is extremely relevant, is that when we embrace a concept like biofortification, we should never lose sight that we are doing this for a consumer. And so we have to take into account the benefits that the consumer will have, but also their expectations. And so biofortification as a target should, or the nutrients that we choose to biofortify the fish with, should be familiar nutrients. We don't want to go into a unnatural concept to the consumer. So nutrients that are already known to be present in fish, or that are in the, let's say, in the perception of people in general as healthy for them. From when we choose which nutrients to target, we have to find the sources. Where will these nutrients come from? And so we have to find natural and sustainable sources, sorry, with a good fit with the consumer expectations also in terms of healthy eating habits. Of course, all this has to be done in strict compliance with legal and safety use limits. And of course, in the project, we took special care of making this industrial relevant use. Sources of nutrients were available in the market that would not drive a huge increase in cost, that would not change the manufacturing process as it is. And as a second layer of concerns that we should have when we are doing this biofortification, in no way should this compromise the growth performance of the fish and the welfare status. And also, it should not bring additional environmental burdens associated to the aquaculture activity as a whole. So in the project, we tested various scenarios. We had two-stage activities, one which was run at pilot scale to define testing various types of fortification strategies to find the best one, that afterwards were tested at the farm scale in a real fish farm. And the concept that we used was, we used seaweeds as a source of iodine, microalgae as a source of some omega-3 fatty acids, in specific case of DHA, and we use a selenized yeast as a source of selenium. This was tested, as I said, in multiple species: gilt-edged sea bream, representative of the Mediterranean; common carp, more of Central Europe and Eastern Europe; and rainbow trout, which is a widespread species. There were also some activities foreseen in Atlantic salmon, and they were also performed. In general terms, we saw no detrimental effects on the growth performance of fish, be it either in the growth rate or the feed conversion. So the feeds didn't alter the performance aspects. There were also no changes on fish physiology or the welfare status of the animals. And by doing some tests with sensory testing, we also found no negative impacts. Here, this is also very important. When you are changing something, you don't want to deviate too much for what is known as the traditional fish. So in general, biofortified fish showed a higher nutritional contribution to cover EFSA's daily recommended intake, the DRI, of the target nutrients. You can see here in this table that some of these aspects were, for instance, for EPA, this is calculated for 150 gram servings of fillets, of course, and this is something that you can see. Sorry, because I have here a double screen and it's creating me some problems. But what we have is for sea bream, we see that iodine, being a marine species, is a little bit harder to fortify. For selenium, however, it was very effective. We reached a higher, on a relative basis, 44% higher levels of selenium. And for EPA and DHA, we are also 45% higher, but we already well above the DRI recommendations from EFSA. In the case of carp, iodine worked. All the nutrients that we target worked pretty well in terms of fortification, and this was one important aspect. This was done in full compliance with the maximum EU limits for iodine and selenium in aquafeeds. And so, because we have data, especially from the pilot scale trials, demonstrating that if we go higher, we can get a higher fortification rate. However, this would not be in full compliance with the current legislation on aquafeeds. In the case of trout, we have done a slightly different approach. We target only iodine, and we use the iodine-rich seaweed, Saccharissima latissima, produced by integrated multi-trophic aquaculture, which was made in association to a salmon farming site in Norway. So for those of you who are less familiar, the concept in a simplistic way again, is that the nutrients that are somehow released from a cage of salmon would serve as nutrients to grow algae or seaweeds in an adjacent area. This is a concept that is gaining also quite a big interest because it brings clear environmental benefits, also generates or is associated to economic benefits because seaweeds have a commercial value, so they can be sold, and this also leads almost to a new industry in which we can generate new jobs. And you can see here in rainbow trout that again, when we target only iodine in this case, there was a clear benefit of feeding the fish with this iodine containing algae containing feed. So also one of the aspects that we assessed was, is this industrially feasible? And so we assessed this at two levels because it implies the participation of at least two sectors, which is the feed mill. So for all cases that we tested, the availability of fortification raw materials is industrially available. There is no limitation on that aspect. Of course, the fortification itself has a cost, so this has to be translated along the way in some way. There is no changes on the current feed manufacturing process, and it is complying with all legal obligations. For the farmer, no changes on production performance, on animal welfare. Biofortification efficacy, as I showed you, is demonstrated, not extremely high in the case of iodine for sea bream, but legal compliance is also okay. And we also, although we have not studied it in detail, we can somehow identify that as a message to the market, we are using sustainable ingredients and we are fostering a natural and healthy image of the products that are being associated to this. Potential constraints, there is as I mentioned, high levels of biofortification can be achieved without detrimental effects on the fish welfare, but we are currently limited by maximum authorized limits in the feeds. The full economical feasibility is dependent on a product and potentially cost differentiation, positioning at the retail level, because as I said, fortification has a cost. And the integrated multi-trophic aquaculture approach, which is something much more recent, requires to some extent the extension of exploitable areas, further R&D effort on algae production in terms of what species are the most adequate, the special planning of positioning, the standardization of quality and safety criteria of these algae, because they can also accumulate some, let's say, elements or compounds that have a legal framework associated. The impact of all this is that for those of you, again, which are less familiar, iodine deficiency is the world leading cause of preventable brain damage. And in a recent European project, it was identified that up to 36 million Europeans are exposed to ID disorders. Suboptimal selenium status was also reported to be widespread through Europe, UK, and the Middle East. And also in a study done by the research community, in 74% of the countries, and 17 of those were EU countries, EPA and DHA intake was below EFSA's recommendation. So to conclude, I would say that biofortification of farm fish is an efficient and cost-effective approach to naturally raise the intake of some of these nutrients and mitigate the associated deficiencies or suboptimal intakes that we have identified. So to conclude, I would like to thank you, but I would also like to mention that this was a huge effort, because you can imagine that I'm here presenting just the very sum up of the data on iodine and selenium and EPA and DHA, but we have analyzed many other components of the fish, and this implied a very, very strong research effort from several academic partners, but also from several industrial partners, because some of these trials, as I mentioned, were done at the farm scale in real life conditions. Thank you very much.